All right, so in a previous post, I actually went over how to do a queue from stack algorithm with Java. Now I'm going to show real quick how to do that with a language I like to use a lot called Haxe. And just to show you, you can achieve it without like a special Java stack object and things of that nature. But I encourage you to kind of read through the post that I have. I go into explanation on what a stack actually is, and this is actually, I'm kind of showing a draft of the post here, so ignore any like spelling issues. Hope to get those cleaned up after I record this. But basically I show actually some Haxe examples on how to actually do the same stuff, so I just want to go over that real quick. So what we're going to do is we are going to create a new project, and I use IntelliJ. So I'm going to be creating a new project, and I'm going to create a Haxe project. So I'm going to hit next, and I'm going to say queue from stack Haxe example. Nice long name so I don't override my other Haxe example that I have. So I can cheat a little bit while I am recording this. I'm just going to kind of copy and paste some things over, but hope to just kind of build this for you guys from scratch for the most part. So what we're going to do is we are going to create a new Haxe class, and let's just go ahead and create main. And we're also going to go ahead and create a new Haxe class called queue. Just like that. So we're going to do a lot of work in the queue class first. So what I'm going to do first here is I'm going to copy over some variables. So just above here, we're going to create an old stack, a new stack, and a top element integer. These are both going to be arrays, and they're going to hold integer types. And this could actually be whatever you want. This should work with just about anything, but for now, just for our simple example, we're going to use integer values. And then what we're going to do is I'm going to copy over the enqueue function. So what the enqueue function is going to do, and I'm going to actually change that to a lowercase. So what we're going to do is we have a variable that we're going to return a Boolean value. That way, if anything goes horribly wrong, we're going to, trace that statement to the console, and we're going to return false, basically that this thing failed. So later, if you're using this, you can check to see if the enqueue failed or not. So all we're doing is we're actually just pushing the element to the array. If you've used arrays in the past, then you're pretty familiar with how that works. We're basically just saying, hey, new stack, here's a new element. I want you to add that to it. And then we're going to have a dequeue public method. And what the dequeue public method is going to do is it is going to instantiate the top element, make sure that it's always -1 when it gets called. And then we're going to check to see if the old stack's length is basically greater than or less than or equal to 0. That way we know it's empty. If it's empty, then we're going to look at the new stack, and we're going to say, give me the top element, and we're going to push that top element onto the old stack. This old stack, you can look at it like this. Our old stack is actually our queue. Basically, it's responsible for anything that gets put into the queue in order. So let's say we put a 1, a 2, a 3, a 4, and a 5. Anytime it's a queue, all that basically means is first in, first out. If the user or the program puts a 1, a 2, a 3, and a 4 in here, anytime we get something from the queue, we expect to get those items back in the same order in which we put them in. So if I put in a 1, a 2, and a 3, then I'm going to get a 1, a 2, and a 3 out of it in that order. I'm never going to get 3, 2, 1 or a random number. I always know what to expect when it's a queue. So that's why we're specifying that this is a queue. Now a stack, on the other hand, basically anything you put into it, if you put in a 1, a 2, a 3, and a 4, then you would get stuff out of the stack in reverse order. You would get a 4, a 3, a 2, and a 1, just like that. So that's important to just kind of keep that in the forefront of your brain when you're working through this algorithm and you're writing it. So now what we're doing here is we're saying old stack, if your length is 0 or less than, then we're going to add a bunch of stuff from the new stack, and we're removing things from the new stack. And we're putting them into the old stack, so into our queue. So we're removing things as we see fit in order, and we're putting them in here. So then what we do is we say, hey, if the old stack length is greater than 0, then we want to return the topmost element when we remove it. In other words, in the order in which we've received it. So in essence, we should be returning things back from the queue to whatever thing is calling these methods in order in which we've received them. So a couple of other convenience methods that I'm going to add in here, and you'll see how those get used here in just a second. I'm going to add these right up here at the top. This might look a little bit different on the blog post. They might be at the bottom. It doesn't really matter. I'm just going to add them here because typically when you're doing getters, I tend to put them up at the top. So anyway, so what we're going to do now is we're going to have a method that basically checks the size, and this is going to get the size of the old and the new stack length combined. So if we have anything in either one of these queue or the stack, then we'll know it. And then the other method we have is an isEmpty method, and this just checks to see if these guys are empty at all. And it's just going to return a true value if they are empty and a false value if they are not empty. So now what we're going to do is jump over to the main method here, and we are going to write a copy over some other code, just some really simple code actually. So let me just copy all of this and I'll talk through it real quick. So let's grab that, and now we just have a method that we run when this object gets instantiated, and we're going to instantiate it here whenever the main class runs. So what's going to happen is we're going to create an instance of the queue, and then we're going to trace just to make sure, hey, is the queue empty? It should be because we haven't put anything in it. And then what we're going to do is we're going to add stuff to the queue. So in our queue, we're going to add 0 through 10. Actually, you could make this whatever number you want. Let's just say 50, just for the heck of it. So what we're going to do is we're going to just say queue in queue add this integer value, whatever we are in the for loop, and then we're just going to trace that to the console. So once we've added all of these items to the console, what you should see is everything's going to get added in order, and then we're going to trace and say, hey, are you empty? And the empty value should return false at that point. So then what we want to do is we want to get the size of the queue, and just for our sanity check here, let's just trace what is the size of the queue. And we're going to say size right here. So this will just prove, hey, are you empty? This hopefully will say false. And then we're going to get the size, and we're going to trace that out. This should say like 49 or 50, whatever. It actually should say 50 whenever we trace this out. And then we're going to say if the queue is not empty, we're going to run a for loop, and we're going to do it over the size value, and then we're going to dequeue the object once for every time we have something in the queue we're going to say, hey, give me whatever is in the queue. And the queue's responsibility is to give it back to us in the order in which we added it. So the first value that we add is going to be a 0, and then a 1, and then a 2, and so on and so forth. So we should see this trace out 0 through 50, and then this should trace out 0 through 50 as well. Whereas if we weren't using a queue, we would see items come back in reverse order if we were just asking for each item that we put in, we would be getting the same item back. And I'd go into a little bit more of a layman's terms on how that works on the blog post, so definitely just skim through that. I'm sure you'll get it. This is a really basic concept to understand, but it's a really good exercise to do in just about any language, and it'll help you kind of brush up on your problem-solving, algorithmic skills, especially if you're going out for some coding interviews and things like that. So what we're going to do now is we're going to actually set up and run this thing. So let's create a new file here. Let's do a build.xml file. And then in here we need to say cp src. And then we're going to say main is main. And then I always forget this because it's been a little while since I've done this. So for compiling our stuff, I don't think this really matters because we don't really care if we build anything, because I'm actually going to run some code in the terminal window to run the Haxe program directly. So what we're going to do now is we're going to open up a terminal window, and this should be in our Haxe examples directory here. So what we actually should be able to do is we didn't even really need this build.xml file. What we want to do is we want to say Haxe, and I think it is cp src, and then main. I'm going to say main, and then we're going to say I think it's 2 slashes in terp, like that. If it's not 2 slashes, then we'll get an error, and if it runs, then it runs. We'll figure this out kind of in real time here. Okay, Haxe. Okay, so we have an error. Type not found, error. Oh, that's right. I forgot to add my import statement for that. So let's go back to the queue, and let me grab that real quick. Let me copy this over just to make sure that I get that correctly. So we just want to import this error object that we were using right here in this catch. So no big deal. So let's try this again. All right, so much success. So what you're going to see, let me scroll back up here and kind of talk through what happened so that we know that this worked. So we're basically going to say, is the old stack empty? And we say true. And then you notice we are adding 0 through 49. And then we say, hey, is the queue empty? And we say false because it has a lot of stuff in it right now. So we say, what's the size of the queue? And it is 50. So then we proceed to dequeue each item in the stack. And as you can see, it is sending that back to us in the order in which we put those items in. And then we ask the stack one more time if it is empty or not, and we get a true value back. So we've had a lot of success here, and that's pretty cool. What I'd like to do is continue to post these algorithms that I'm practicing online. If you guys have one that maybe tripped you up in a coding interview or something simple that you want me to go over, I am definitely looking for recommendations. So please, send those to me on Twitter or post them in the comments on YouTube or on the blog. I'm definitely looking to do, maybe one of these a week or something like that, just to kind of brush up on my skills and also help you guys out at the same time. So let's help out the community, and just let me know if you need anything else, or if you run into a problem with this, or if maybe you see something that I could have done a little bit better or whatever. I'm definitely open to suggestions. And that's it. Have a good day. I really appreciate you for watching.